Class 1 Electric Basics. So what is charge? Charge, electric charge of a property of a matter is the property that causes to experience a force when the material or object is kept in an electric or magnetic field. So electric ಅಥವಾ magnetic field ಅಲ್ಲಿ when you place anything, if there is an attractive or repulsive force, it means there can be electric charge there. So electric charge has electric field around it, and a moving electric charge has magnetic field. Electric charge ಅದರ ಪಾಡಿಗೆ ಇದ್ದರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದ್ದೇ ಇರುತ್ತೆ, ಬಟ್ ಅದು ಮೂವ್ ಆಗ್ತಾ ಇದ್ದರೆ ಇಟ್ ವಿಲ್ ಹ್ಯಾವ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಆಲ್ಸೋ. Let us make this short. Has and a moving electric charge generates a magnetic field. Combination of electric and magnetic fields is known as electromagnetic field. Interaction of the charges generate electromagnetic force. This is the foundation of physics. Positive and negative. There are two types of charges. So protons are positive, electrons negative, neutrons zero. When you say some body is negatively charged, it means number of protons is lesser than number of electrons. If it is positive, more protons. If it is negative, more electrons. It is see, charge of an electron is very small, hence we use bigger charges. For example, we talk in rupees, we don't talk in paise, because paise is very small, and for large business organizations they talk in millions. They don't talk in rupees also, they talk in crores of rupees. So similarly, 1 coulomb means charge due to 6.2 into 10 to the power of 18 electrons, or 1 electron charge means it will be 1 by 2, 1 by so much, so it will be so much. So charge of an electron is 1.6 into 10 to the power of minus 19 coulombs. Laws of charges. Like charges repel, unlike charges attract. ಸಜಾತಿಯ ಚಾರ್ಜ್ಗಳು ವಿಕರ್ಷಿಸುತ್ತವೆ, ವಿಜಾತಿಯ ಚಾರ್ಜ್ಗಳು ಆಕರ್ಷಿಸುತ್ತವೆ. Then this magnitude of the force of attraction or repulsion is given by product of, it is given like this, K into Q1 Q2 by R square. Q1 and Q2 are individual charge values. R is the distance between the charges. So if you have Q1 here and Q2 here, R is the distance between them, then the force of attraction or repulsion is proportional to the product of Q1 and Q2 and inversely proportional to distance R square. This all you have studied in your 10th standard, or you will study in, okay, now science is not there for you in C20 syllabus. Okay, the proportionality constant K is equal to 8.8 into 10 to the power of minus 12 Faradays per meter. Now, how to charge and discharge a body? Process of supplying charges or losing charges, both are called as charging. Some say discharging. Actually, if you remove electrons or put extra electrons, both are called as charging. If you remove electrons, you are actually positively charging. If you put extra electrons to a neutral body, you are charging it negatively. Positive charge means, but some say positive charge means gaining negative charge. Okay, sorry, because losing positive charge means gaining negative charge. So in that context, the charging and discharging, the word, we should actually correctly express it. So you can have three ways of charging: friction, conduction and induction. See here, by friction, there is a cloth which is initially uncharged. There is a plastic rod which is initially uncharged. You rub it together. What will happen is, the rod has tendency to lose electrons. The cloth has a tendency to attract electrons. So from glass rod, some electrons will flow into the cloth. So cloth becomes negatively charged and plastic rod becomes positively charged. So this is by friction. Next, by induction. Next is by conduction. Okay, this is same. See, this rod is there, you rub. When you rub, what happens is, the cloth becomes negatively charged, this becomes positively charged. Now if you keep them separately, now these two will have a tendency to attract each other, because this is positively charged, this is negatively charged, and they will tend to neutralize if you bring again into the contact. Now see here, for example, what is charging by conduction? Assume that initially there is no ebonite rod. Initially this is metal sphere, but it is insulated. Okay, you have a negatively charged rod, ebonite rod, say it is negatively charged by some other process. You bring that into the contact of this metal sphere. Now this metal sphere is neutral, but this has excess electrons. But due to physical contact, some electrons will flow from the rod to the metal sphere. Then you move away the rod from the sphere, metal sphere. Now what will happen is, in the metal sphere there will be excess electrons. So this metal sphere is now negatively charged by conduction. Okay, this is insulator. Suppose say this is a conductor, then these electrons will flow to ground. Again the body will become neutral. Next is by induction. In induction what happens is, similar to conduction. Now see here, you are not touching here. The sphere is initially neutral, means number of electrons is equal to number of protons. Now when you bring the negatively charged rod near to the metal sphere, this is insulator. Otherwise, while doing the process, all the electrons will flow to ground. Now this is brought closely to the stand. What will happen is, since this is electrons here, more number of electrons here, it will push electrons which are close to the rod to the other side. So electrons will move from left side to the right side. So here the right side will become negatively charged and the left side will become positively charged, but only for a temporary period, because when you remove the rod again, this will redistribute and become neutral. As a whole, now the metal sphere is neutral only, because number of electrons is equal to number of protons. But in case of conduction, this is not now electrically neutral, because there is actually flow of electrons from one body to another body. But in induction, there is no physical contact, only rearrangement takes place, disturbance only takes place. So this is by induction. Even by induction you can actually charge. See, by induction you will bring first you will bring a negatively charged conductor to the metal sphere insulated. Now what happens is, this will be disturbed and electrons will be rearranged, means here there will be more electrons, here there will be lesser deficiency of electrons. Okay, now what happens, now for a temporary period you just connect a wire from the right side to the ground. These extra electrons will now flow to the ground. Okay, now remove the rod from here. Then what will happen is, these positive charges will now redistribute uniformly around the sphere, and the sphere will now become net positively charged. So you can also charge in this way. Now what is electric current? Okay, that we will take in the next class.